You've probably tried it. You reach over and tickle your own palm, your own ribs, the sole of your own foot, and almost nothing happens. No shriek, no flinch, barely a reaction at all. Then someone else does the exact same motion in the exact same spot at the exact same pressure, and you're gone, laughing, twisting away, unable to stand it. Here's the part that should unsettle you a little. Your skin can't tell the difference between those two touches. The nerve endings fire identically either way. The difference isn't happening in your hand at all. It's happening somewhere upstream, in a part of your brain that already decided before the touch even landed that this particular sensation wasn't worth reacting to. You're watching Brain on a Leash, where we dig into the strange evolutionary leftovers still steering modern behavior. Let's start with what your brain is actually doing every time you move. Whenever you send a motor command out to your hand, your brain doesn't just send the instruction and wait to see what happens. It also generates a private prediction of exactly what sensation that movement should produce, an internal preview built in advance. Researchers call this an efference copy, and it happens for essentially every voluntary movement you make. Neuroscientist Sarah Jane Blakemore, working out of University College London in the late 1990s, used this exact idea to explain self-tickling directly. Her team found that a structure called the cerebellum compares your predicted sensation against the real one, arriving a split second later, and when the two match closely enough, it quietly dampens the response before it ever reaches conscious awareness. Here's the sentence worth remembering. You don't fail to tickle yourself because your hand isn't ticklish. You fail because your brain already knew exactly what was coming. Now here's the part that should genuinely surprise you. This isn't a minor quirk of the tickle reflex. It's the same system responsible for something you rely on constantly without noticing. The reason the world doesn't feel like it's shaking every time you turn your own head. The reason your own voice doesn't startle you the way a stranger's shout would. Your brain is running this predict and cancel routine almost continuously, filtering out the enormous stream of sensation that your own actions generate, so that what's left standing out is only the sensation that came from somewhere else. Tickling just happens to be the one version of this filter you can consciously catch in the act. Has this ever happened to you? That split second where a friend fakes a tickle and pulls back before touching you, and somehow it still gets you? That's the prediction system briefly losing its footing, uncertain whether the touch is really coming, unable to fully cancel a sensation it can't quite forecast yet. There's a reason evolution would build something this elaborate just to stop you from tickling yourself. A nervous system that reacted to every touch identically, regardless of source, would be constantly startled by its own body, flinching at its own footsteps, jumping at the brush of its own arm against its own side. Being ticklish at all is believed to have served as an early warning system, tuned specifically to detect something crawling or creeping across vulnerable, hard-to-see parts of your body, like your ribs, your neck, the soles of your feet, exactly the places a predator or parasite might go unnoticed. That system only works if it stays specifically reserved for touches your own brain didn't order. We touched on a version of this same idea in our video on why you unconsciously copy the person you're talking to, a system quietly deciding, without asking permission, what counts as coming from you and what counts as coming from someone else. This is that boundary drawn even more precisely, tested touch by touch, prediction by prediction, thousands of times a day, so reliably that you've never once had to think about it. So the next time someone else tickles you and you're left wondering why your own hand could never manage the same effect, remember what's actually happening. Nothing about the sensation changed. What changed is that, for once, your brain genuinely didn't see it coming. If this changed how you think about that reflex, that's exactly the kind of small evolutionary detail we chase down around here. Go check out our video on why you unconsciously copy the person you're talking to if you want another one. Until next time, keep your brain on a leash.